in groups of 2, you are to come up with 4 different ways. Ahmed, one person, is going to do 2 packages. Garrett, the other person, is going to do 2 packages. So 2 each. Not one person does 4, the other person does nothing. Okay? 2 each. Alright? So what that means is you and your partner are going to design, in total, 4 different packages for your balls. Right? So design 1, which I think nearly everyone will do, is a cylinder. Okay? It's compact, it's easy, it fits nicely on it. Remember, these packages are going to be sitting on a shelf in a shop, like Rebel Sports. You go in there, you buy your balls in a cylinder. It's a really good sort of package, okay, for balls. So, that could be design number 1. Design number 2. Depends whether you've got 4 or 6 or 8, might depend on how you set it out. If I have 8 balls, I might decide that a cube's a good one, a cube, because I can have 4 on the bottom and then 4 on the top. 4 and 4. Works well for 8 balls. Maybe not so good for 6, because then you've got a lot of space left. But if I've got 8 balls, I'll probably do a cube. Okay, it's a good one. Design 3, I might do a prism. This would be good for any number of balls. A bit like this one, except it's got, straight edges. I might put the balls in here this way. 6, 8, 4, whatever. Okay. So what you're designing is 2 different types each. So in total there are 4 packages, and easy, simple, solids, like packages. Not anything difficult. No pyramids, no cones, no something where they're complicated. Okay, really basic shapes. Okay. One that's quite popular that people do is that if you want to make it a little bit harder, I don't care what the shape is. Like, don't pick something hard because you think you're going to get more marks because it's a more complicated shape. It's not about how complicated the package is and how you can work it out. Okay, it's not. That's not what we're marking. They've got to be a package that you think you would see on a shelf in a shop. So obviously some complicated pyramid probably isn't going to be what you're going to see. You're not going to buy balls in a funny pyramid sort of type shape or a cone. Okay, it doesn't work. Okay, I know these are basic and for a lot of you the maths is really, really simple, but it's not really about the maths. It's really about putting together the whole thing, the whole assignment, putting it together. Okay, thinking of the 4 designs. Even though these are ones that you see anyway, that's okay. So sometimes I've seen this before where they put like a hemisphere on top, if you want it. Sometimes people put one on the bottom as well, and then you put your balls half in there, 3, however you want, okay? But hemispheres are okay. We've got formulas to work out surface area and volume of spheres, so that's all okay. I don't want complicated, unusual. One of the boys in my other class has got this shape, which, this is what he wants to do. Yeah. And I'm thinking, why would you pick something like this? But anyway, that's with the hole in the middle, and he's going to put his balls around, And it's like, I was thinking, you're not going to get more marks for the maths, okay? It's not about picking something complicated. It's about actually picking something easy, okay? And practical. So if I go buy some balls in a package, like, this is what the company's going to probably want to sell it in, okay? This will be probably cost too much. It will cost too much to make anyway, because it's got to be a surface area. So please don't think it's got to be complicated. It's actually got to be really simple, okay? The easier the better, all right? Or you might want to have, so what's, you might have 2 balls in the front here, like, 2, and then 2 behind, or 6 or whatever. Just simple, Simple prisms, cylinders are always really good to decide what you're going to do, okay? So 2 each, they've got to be 4 different. Now, if you've got 6 here, and this is another package, these packages are actually different. Even though you'll have the same surface area, it doesn't matter, but that actual package is different to this package. They're actually different, even though you might have the same volume and the same surface area. That doesn't matter, but they are different packages. So don't think, oh, I can only do 1 prism. You can actually do 2 sorts of prisms. Okay. Okay, so this is what we're going to do. Your final report should include the following: an introduction, including a statement of the problem in your own words. This may include key questions that you need to be answered to. You can call your new company a name, and you can say, our company has been asked to design 4 new packages for 6 golf balls. And you're going to just introduce what you're going to do. We are looking at cylinders and prisms to work out which is the best package design that we would like to recommend. So you just, in your own words, introduce what you're doing, okay? Including what balls you've got, how many, that sort of thing, okay? Then, all the facts particular to your group. So that's where you say, I've got golf balls, I've got 6 of them, the radius is 2.14 centimetres, so you put in the information that you're linking to the group. Now, for each of the 4 packages, this is what you have to do. You have to have a sketch or a photo, no one does photos, I just draw it, of the configuration of the balls as they would be within the package. So what that means is, the first thing, let's do the cylinder, that's the one I like. There's my cylinder. So the first sketch, so this is my, say it's my design, so sketch 1. I'm going to draw my package, sketch of the configuration of the balls as they would be within the package. So I have to draw a sketch with the balls sitting inside to show me how they're going to sit in the package, okay? Sketch number 1. Now, then we're going to do, this is number 1. Sketch of the net. Now, did you look at nets when you open it flat? If I cut the shape up and open it flat. So sketch 2 of a cylinder. If I cut it along you have a rectangle and you have a circle, top and bottom. There's my net. So sketch of the net, including dimensions. Okay. So this one you just show me with the balls. This one, you have to put in the dimensions. Say I've got 4 tennis balls. So that's Ahmed and Garrett, right? I'll put 3.25 centimetres there. And I've got 1, 2, 3, 4. So this would be twice that. 6.5, 6.5, 4 of them. So I think that's 26 centimetres. So in the second sketch, you tell me how big is, what are the actual dimensions of your actual. Now you don't have to draw it 26 centimetres on the page. You draw a little one and you just tell me what it is. Okay, please, I don't want pictures that big. It's unnecessary, okay? So how did I get 26? The radius is 3.25 centimetres. The diameter is double that. So that would be 6.5 centimetres. So that's 6.5, 6.5, 6.5, 6.5. So 6.5 times 4, okay? So you have, depending on how many balls you've got, what the diameter of the balls are, you can tell me how tall your package is going to be. So this picture, no numbers, just the balls, how they're going to sit. This picture, open it up. It's a net, and you put the dimensions in. So in total, when I open up your report, assignment, you're going to have 8 pictures. 2 is design 1, 2 for design 2, 2 for design. Okay, so in total there's got to be 8 sketches, 2 for each one. Is that okay?
Yes.
That's the first thing, right? That bit shouldn't be too hard. Okay. Now, that's this and this. Number 3. Calculation of the surface area of each package, including formulas used. Okay, so this is the first bit, then I'm going to do surface area. Now, what is surface area? This, and this. It's the area of the whole package, okay? Now, you had Mr. Bernard on Monday. And did he go through some formulas with you?
Yeah.
On surface area? So to say the surface area of a cylinder, 2 pi r squared plus 2 pi r h. This is pi r squared, the circle, area of a circle, pi r squared, so there's 2 of them, 2 pi r squared.
Yeah.
The area of this is 2 pi r h, that's my formula. And I'm going to work out how much area my package is my package. Okay? Right, work all that out. 2 times pi times radius, 3.25 squared, plus 2 times pi times 3.25 times 26 is my height. Work all that out. You get an answer. Okay? That is the surface area. That's how much packaging I need. The top and the bottom of my cylinder and the curved part of my cylinder. And then I'll get some answer. Centimetres squared. Area is in centimetres squared. Is that okay?
Yeah.
You get the formula. You put in your information for radius and the height, work it out on the calculator. Now, if you want to, you can write your answer to the nearest whole number if you want to, or 1 decimal place. You decide, okay? It doesn't really matter, okay? And if you want to, maybe we should all do it just to the nearest whole number. We do that, so everyone has the same, to the nearest whole number. So if you get a decimal, then, okay, so you round up to the nearest, so where's my calculator? Okay, let's just quickly work it out for, just as a demonstration. So, 2 times pi times 3.25 squared plus 2 times pi times 3.25 times 26. So hopefully I've pressed the right buttons, no mistake. And what you get is 597.29 ... But let's round up to the nearest centimetres whole number, 597 centimetres squared to the nearest whole number.